Hello, everyone. How are you? Thank you for joining us today for this session. Um, we have a good number of attendees coming in, so thank you. We shall just wait for a few more before we start. But a few housekeeping rules. We will be recording the session, so please keep that in mind. The session is also being live streamed on our YouTube channel. So if you'd like to have a reference point, please make sure that um, you can have access to our YouTube channel. Um, we shall be having different speakers from across different regions across the world. We shall be bringing them in a few minutes. Before we do that, I want to first record. Thank you. So welcome everyone. Welcome to the room. We're very glad to have you here. Today we'll be talking about how to accelerate heat pumps and especially looking at the deployment of the heat pumps, looking at policy, the markets, and lessons from particularly emerging economies and countries. So today we have a few speakers lined up. We have speakers from Australia, from New Zealand, Thailand, Indonesia, and India, and we're very glad for the experts who have put in so much time here. I want to now first welcome Duncan Gibb, who is the Senior Associate for Europe Program at the Regulatory Assistance Project, that is RAP. I will not read his full bio, but Duncan is an energy policy expert specializing in clean heating technologies and heat pump economy. He currently works with RAP, where he leads the European research on the economies and policy framework supporting heat pump adoption and low carbon heating systems. Welcome, Duncan. Please give us a few opening remarks from a global perspective. Thank you.
Thank you, Rahima. Good morning, good afternoon, good evening, everyone. As mentioned, my name is Duncan Gibb, working at the Regulatory Assistance Project. We're a global NGO that focuses on the clean energy transition. We work with governments and industry around the world to try to get some of the best policies in place. And a big focus of myself is on heating. At RAP, we also run something called the Clean Heat Forum, where we bring together governments, industry, and civil society to discuss innovations in clean heat policy. This is something we've been doing for the last few years. So through these efforts, we've gotten a good overview of kind of what are the big heating, I should say, and cooling challenges around the world, and what role do heat pumps play in this. So first off, I think we can put it in terms of emissions. We know that emissions are not the only reason you would want to switch to clean heating nowadays. There's obviously some very large crises in fossil fuels taking place at the moment, which only reinforce the need to phase out these fuels from our heating and move to cleaner and homegrown technologies. But on the emission side, it's a big case as well. So we know that according to the International Energy Agency, in 2022, we had around 2,500 megatons of CO2 equivalent that was consumed for space and water heating in buildings. So 2,500, that was around 59% natural gas, 26% oil, and 15% coal. So a big part of that is gas. And according to the IEA's net zero scenario, by 2030, we want to get that number in buildings down to 1,250. So that's a decrease of half. And to put that into context, these levels of emissions in buildings for space and water heating have more or less been flat since 2010. So we're not really moving the direction that's needed yet. A big cut in them is required, and this concerns all fuels. So this translates to the fact that we only have in 2024 around 16% of our heat in buildings was supplied by renewable energy. This includes everything from bioenergy to heat pumps with electricity for heating, solar thermal heat, geothermal heat, obviously taking up a larger proportion. Of this 16%, about half of it, 8%, was from heat pumps and electricity for heating. So we're really going to want to increase these numbers if we wish to reduce the emissions, as I mentioned. But it isn't only about emissions. I mentioned, heat pumps harness this ambient energy, which is already renewable. This means that we're not combusting a fuel on site. we're able to use already available energy in a very efficient process. So this will already reduce your on-site emissions and even life cycle emissions, no matter how dirty your energy is, your electricity is. Only in kind of the countries where the electricity is the most based on coal could we have a bit of difficulty with emissions reduction. But in many countries, especially as we see the electricity supply greening, this is less and less more and more the case that heat pumps will reduce emissions. Now, on the other side, they're also efficient. So we know that heat pumps produce around 3 to 4 units of useful heat for each unit of electricity consumed. This is called the coefficient of performance. So if you take this, compare this to a natural gas boiler, which might use 90% or 95% efficient, it's around 4 times, 5 times more efficient than that. So not only are we not burning a fuel, but we're also producing heat in a much more efficient manner. Heat pumps are also cost effective. So due to the energy savings they provide, they can achieve running costs that are similar or better than fossil fuel heating. We've seen multiple national and international analyses that have shown them as the critical cost-effective technology for decarbonizing heat. Whether they're cost-effective obviously depends on the energy prices locally. These prices sometimes are driven by taxes and levies on electricity, which we've looked at in Europe, for instance, and across the globe as well. We've had a paper on this recently, that oftentimes we see a lot higher taxes on electricity than natural gas. It's something that governments really need to look into. And relatively low electricity prices are also associated with heating electrification. So the more we can drive down electricity prices, the more electrification of heating will take place. And finally, on the cost-effective point, even in countries like the UK, combining a heat pump with solar in a country that's not very sunny can immediately be a cost saver and running costs. So these have a technological combination that's very favorable to cost reductions. I mentioned this point briefly at the beginning, but heat pumps also deliver big on energy security. So we know that they can reduce the imports of fossil fuels for countries that depend on them. They run on homegrown clean electricity. And this is really there's a big push now, I think there will be, to see the uptake of heat pumps from this perspective. So not just the energy savings or emissions perspective, but also energy security. So that kind of brings me to the end of my remarks that lay out a bit the case for why heat pumps are important these days. I'm really excited to hear from the presentations today. We have a wide range of countries that are not talked about very much on a global level in terms of heat pump usage. So it's really keen to hear what's taking place in these various geographies, and looking forward to the discussion. Thanks very much for having me.
Thank you, Duncan. Thank you for the very good context. And now over to Dr. Peter Graham, who's the CEO of GBPN, and he has more than 20 years of experience in both international advocacy, research, and education in sustainable building design, construction, and evaluation and policy. So please come on board and tell us a little bit about the decarbonization heating and cooling systems and IBI buttons.
Thanks, Rahema, and hello everyone. It's fantastic to be here. Thanks, Duncan, for that really important context. Global Buildings Performance Network, GBPN, we're a global network of local experts, and we work to decarbonize the building sector. So working on policy reforms that incorporate market transformation measures to increase the deployment of heat pumps and encourage electrification is really a very important element of that. And GBPN's been collaborating with RAP and Agora and CLASP over the last few years on this project, which is to support the development of a policy toolkit and disseminate best practices that promote market development, market transformation, and deployment of heat pumps. And we focus on the building sector policies and how we can improve performance standards, regulations, and enabling policy frameworks to support decarbonisation and the aims of electrification and so on. GBPN works mainly in emerging economies in the global south, and we've got programs in Indonesia, India, China, and Africa. And we also inform global initiatives under the Buildings Breakthrough. And as was mentioned, you know, in order for us to sort of maintain a track to achieving the Paris Agreement goals, the building sector has to halve its emissions by 2030, which is an extremely ambitious requirement. And so we're really focusing on how we can support policy reform in these rapidly urbanizing economies to see zero emissions regulations in place from 2030. If we can get there, we're going to be able to get these major economies on track to decarbonisation by 2050, just because there's so much new building activity and a lot of stock to be developed between now and then. It's also really important to decarbonise the existing building stock and through retrofit programs. And it's really interesting to see some of the examples that hopefully we'll hear about tonight from places like New Zealand and Australia, where there's been quite some success in encouraging retrofitting. But to say that also with some of our other countries represented on this webinar, that there is certainly cooling demand, which is a very important part of the decarbonisation story. And so I'm really interested to hear some of the experiences from you know, India and Indonesia and Thailand around potential for perhaps heating reductions in industry or industrial buildings, and also other opportunities for sort of hybrid approaches, so where we can look at combinations of heat pump, water heating, cooling, and so on. So what are the kind of the palette of opportunities that we've got in the policy space that's going to enable us to really engage and drive decarbonisation in the global south? So very, very excited to be part of the program. Very happy, and thanks to the team of GBPN Africa and globally to support the facilitation of this workshop today. And yeah, I'm really looking forward to the presentations and also the discussion later. Thanks, Rehema.
Thanks, Peter. And thank you for mentioning that you're excited. I'm also excited to hear a little bit about the country. So we'll start with our first speaker, who is an expert from New Zealand, Dr. Glenn Seymour. He specializes in the design, implementation, and management of effective and practical projects, the purpose of delivering specific energy efficiency and decarbonization outcomes across a wide range of sectors. He has worked in both New Zealand and Australia, particularly for local and central government agencies, looking at projects to do with space heating, water heating, human solution, commercial energy audit programs, and among others. He has also contributed to the development of the regulatory impact statements for improved minimum energy performance standards for heat pumps and other product categories within New Zealand and Australia. Welcome, Glenn.
Thank you, Rehema. Good evening if you're on my side of the world, or good morning or good afternoon if you're elsewhere. I'm going to talk about heat pump deployment in New Zealand. Next slide, please. So just a bit of context, New Zealand has a population of 5.3 million people spread across about 2 million households. Virtually everybody lives in the two main islands that you can see to the right of the screen there, imaginatively named the North Island and the South Island. We have a temperate maritime climate with winter daily highs between 7 and 15 degrees. And in the South Island where I live, it's quite common in the winter times for there to be sort of a small frost in winter. So yeah, we do get some cool temperatures. Next slide, please. Heat pumps are the dominant form of heating in the New Zealand market. We sell about 200,000 heat pumps per annum across New Zealand. Just by way of comparison, we sell about 15,000 gas heaters and about 13,000 solid fuel burners. So heat pumps are well and truly the go-to form of heating in New Zealand. Approximately 2/3 of households use a heat pump as their main form of heating, and most new homes have a heat pump installed at the time of construction. The reason for the state of the market is the obvious energy efficiency and lower running costs of a heat pump. There's been a number of government policy, regulation, incentives programs operating for over 20 years now that have promoted heat pumps as a clean, efficient form of heating. They're obviously very convenient and easy to operate. The New Zealand market is predominantly a heating market, but in the northern parts of the country, cooling capacity is something that is considered to be a value in the warmer months. Given that heat pumps have been popular for over 20 years now, we've also got the situation where we're into the replacement market for older heat pumps that might have been installed and are now failing or at the end of their economic life. In New Zealand, we tend to just heat the main living rooms of our house rather than having whole of home systems. So the majority of heat pump sales, 92% of them, are just for single split systems designed to heat one room. There's a huge range of options on the market, over 500 models across 21 different brands. And I did some work recently analysing sales data, and the average capacity of a single split system is 5.7 kilowatts or 12.5 for a ducted system. Next slide, please. There's a range of financial support available for heat pumps. Predominantly, the main source is the government's Warmer Kiwi Homes program. That's been operating for about 8 years, but there's been predecessors going back to about the year 2000. It's been focused on energy efficient and healthy homes for low-income households. So it requires the home to be insulated and then to have a clean, efficient form of heating put in. And there's 90% grants available if you're a qualifying low-income household. So that makes it a pretty compelling proposition to get a heat pump installed. The home must be insulated, and it's for the heating is for the main living room only. There's also been a number of local community grant schemes where they're offered by a community or a charity or an energy trust or something like that for heating and insulation. They are almost always focused on low-income households, and they typically align with the government's Warmer Kiwi Homes program and basically just offer a top-up. So in some cases, the heating and insulation is free. A number of local councils have set up schemes around the country that I've been involved in, whereby they will advance the householder the money to install heating, insulation, solar panels, what have you, and they repay that advance back over their property rates accounts over 5 to 10 years. Those schemes are generally available to all homeowners rather than just focused on low income, and they're all similar but slightly different. And there's a new national ratepayer assistance scheme that's currently in development that will basically bring all those together under a single umbrella. There's also some of the earlier schemes that I've been involved in going back over 20 years have been focused on clean air. So it's a matter of changing out an open fire or an old enclosed burner and replacing that with a clean, efficient form of heating and home insulation. Next slide, please. Heat pumps are regulated in New Zealand. They have been for about 20 years. They require a zoned energy rating label displayed at the point of sale, and they must meet minimum energy performance standards. Those minimum energy performance standards have been changed progressively over the years, and the net result of that is that the coefficient of performance of heat pumps sold here has increased quite considerably over the last few years. One of the biggest drivers for heat pumps in recent years has been in rental properties, which is about a third of the New Zealand housing market. Over the last 4 or 5 years, there's been a requirement for minimum standards for heating, insulation, and ventilation in rental properties. And what that means in practice is that effectively a heat pump is required in order to meet those standards. Our New Zealand Building Code was recently upgraded a couple of years ago to strengthen insulation and thermal performance, but it doesn't mandate any particular form of heating. There's also no requirement in New Zealand for homes to be rated for energy efficiency, although there are some voluntary schemes that rate new or existing homes. Like most countries in the world, we've been phasing out high global warming potential refrigerants like R410A, and now I think virtually 100% of heat pumps sold in New Zealand use R32 as their refrigerant. Potential future policy enhancements could be an ongoing phasing out of gas heating connections. New Zealand is trying to decarbonise and stop relying on gas as a form of heating. We could potentially extend our national insulation and heating retrofit program to include a broader range of households that would open up the program to more. I did some work a couple of years ago with the New Zealand Green Building Council here, and they put together an existing homes roadmap that calls for a deep retrofit at New Zealand's 200,000 worst performing homes. So that would include a move from gas to electric heat pump heating. And I've also put here potentially improved consumer information, such as a heating comparison tool. Next slide, please. There's no tax incentives available in New Zealand for heat pump installation. However, our 4 largest trading banks in New Zealand offer green home or warm home products, and they offer mortgage top-ups at 0 or 1% interest rates for a few years to help install heating, insulation, solar panels, and so forth. Some of the larger heat pump retailers offer periods of interest-free advances, typically of 1 to 2 years, to help customers afford heat pumps. And some of our electricity companies also offer households assessments and assistance with insulation and heating. Next slide, please. So the challenges in heat pumps are less than they used to be because it's now the dominant form of heating in New Zealand. So we've got a relatively mature market. But if I was to talk about some barriers to purchasing a heat pump, I'd look at the capital cost. So if you have to spend $4,000 or $4,500 on a single split system, and you think I can just go down to the local hardware store and buy an electric resistance heater for $100, there's a decision to be made there, balancing the short-term capital cost versus the ongoing energy savings through the much more efficient heat pump. There have been issues in the past with poor quality sizing of heat pumps, which is absolutely critical to their performance and the installation. However, the Energy Efficiency and Conservation Authority here has done some good work over the last few years in terms of producing good practice guides for installation and sizing of heat pumps, which has helped to address that. There's also potential challenges around electrical wiring upgrades that may be required in some cases. And the risk of power cuts is always something that people have a perception of that's, in my opinion, seems to be a lot worse than the reality. But nevertheless, it does make people think about electric heating. In some cases, if you've got an older home, it may be uninsulated, it may have a high ceiling, it just might not be practical to heat with a 7, 8, 9 kilowatt heat pump, and it might drive consumers to choose a solid fuel burner. There's still a bit of a lack of consumer understanding of heat pump technology and how it works and how can they be 400% efficient. It doesn't sound believable to some people. There's a proliferation of makes and models in the market and sizes, which may cause some confusion. And historically, we had the split incentives in the rental housing market, but that's now been effectively addressed through the Healthy Homes standards. Next slide, please. So the opportunities, New Zealanders are finally waking up to the idea of having a whole of home heating solution, and ducted systems are gaining some traction. They've tripled in sales over the last 10 or 15 years. There's the potential to extend government and other retrofit programs to include medium to high income households. We're certainly working towards increasing electrification and decarbonisation. And Duncan, I think you made a point about the level of renewable energy, and New Zealand are sort of up there in that regard, with around about 90% of our electricity being renewable. So we're well placed for electrical heating. We're slowly increasing the number of homes with solar photovoltaic systems. So it makes sense if you install a PV system to move to electric heating to use your own solar generation. Improved consumer information and labelling, explaining the benefits of heat pumps. The replacement market that I mentioned before. The residential construction activity is also highly correlated to the heat pump market and the rising consumer demand for cooling. Next slide, please. And just some closing comments. As I mentioned, the market for at least single split systems for heat pumps in New Zealand is relatively mature. They're the go-to form of heating. There's still some work to be done on whole of home ducted systems. Regulations and government programs in New Zealand have really pushed the uptake rate of heat pumps and also the efficiency through the regulations and labelling requirements. However, there's still plenty of cold homes in New Zealand that need improved insulation and heating. And I think the heat pump market can be further improved by some sort of national plan for decarbonisation and electrification, deep retrofits, as New Zealand Green Building Council is talking about, targeting the more general income households, so a broader range of households, and promoting whole of home heating. So that is my brief snapshot of the heat pump market in New Zealand. Thank you very much for your time.
Thank you, Glenn. Thank you for making that presentation. And it's good to know that the challenges in New Zealand have actually reduced. So thank you. Our next speaker is an expert from Australia. This is Rachel Wilkinson, who is a senior advisor in government relations at the Energy Efficiency Council, also known as EEC. And she focuses on promoting energy efficient products and technologies to support Australia's transitions to net zero emissions. So welcome, Rachel.
Thank you. And thank you for having me or having me back. We can jump to the next slide if that's okay. So in terms of the heat pump market in Australia, like many parts of the world, we are seeing a surge in interest in heat pump uptake for both heating and cooling as well as hot water. This is being driven by cost pressures. There is a growing recognition that these systems are cheaper to run, particularly relevant during a cost of living crisis that we're facing, and I know many others around the world are facing, and also by government policies that are incentivising electrification and in some cases driving the replacement of gas appliances. It's worth noting that Australia is a federated country, meaning that power is shared between the national, which is the Commonwealth government, and individual states and territories. We've got 6 states and 2 territories. Each state and territory has its own authority over key areas like regulation or workforce licensing and building standards in some cases. So as you can imagine, it gets a little bit messy. We do have an agreed national construction code, or the NCC, but there's still some jurisdictional differences, and there's a bit of movement around that code at the moment. So the future of that is somewhat uncertain. Now, I don't have a handy map of Australia like Glenn had of New Zealand, but we also have very diverse climate zones, which we characterise in 8 regulatory climate zones, and that's got everything from tropical to desert to cool, alpine down in Tasmania. So again, there's a bit of complexity there in terms of the climate. So as a result of all of this, policies and requirements affecting heat pump uptake can vary significantly depending on where you are in the country. So again, due to that complex federated structure, we don't have time to cover all of our jurisdictions today. So I'm going to focus mostly on the state of Victoria. 2 reasons: it's a major state, over 7 million people living here, including myself, but also there's a range of programs and interventions worth discussing. So it's a pretty good case study for what we're trying to do today. In terms of regulatory approach, if we jump to the next slide, as I mentioned, we've got our National Construction Code, although the application and interpretation of that can still differ around the country. So in most states and territories, the NCC now includes a 7-star NatHERS rating, and the NatHERS is the Nationwide House Energy Rating Scheme. So this is a rating out of 10, signifying the energy of efficiency of a home. So heat pumps and thermal performance are understandably linked to this rating, but also like New Zealand, it's not mandatory in the building code to use heat pumps. So some states and territories like the Australian Capital Territory and here in Victoria are banning new gas connections in new buildings, which is certainly a step forward and driving some uptake. Also from March 2027, Victoria is also banning the replacement of gas hot water systems at end of life in existing homes. So these will instead need to be replaced with efficient electric systems with a strong emphasis on heat pumps. We've also got minimum rental standards driving uptake. So from March 2027, Victoria will require gas heaters and hot water systems to be replaced with efficient electric systems. Again, strong emphasis on heat pumps at end of life. And there are around 650,000 rental properties in Victoria. So these regulatory and other initiatives in Victoria are part of implementing the state's gas substitution roadmap noting that Victoria as a state is quite reliant on gas, particularly residential gas, due to a range of factors, which I won't bore you all with today. Feel free to reach out offline if you happen to be interested in that niche subject. Next slide, please. So in terms of financial support in Victoria, we've got the Victorian Energy Upgrades Program, which is a state-run energy efficiency scheme that helps households and businesses reduce energy use by providing rebates or discounts on energy-saving products like heat pumps or LED lighting. It operates through a certificate system. So Victorian Energy Efficiency Certificates, which we call VEECs, are created when approved upgrades are carried out. And the certificates are then traded on a market, and the cost is ultimately recovered through our energy retailers, who pass it on to consumers via electricity and gas bills under regulatory obligations. Another government agency, Solar Victoria, offers a separate rebate for heat pump hot water systems. That's $1,000 for any eligible system and $1,400 for an eligible system if it meets the program definition of Australian made, so locally made product. And the other thing to note about these two incentives is that they can be stacked, meaning if you're eligible for both, you can have both at the same time to reduce the overall cost up front. Next slide, if that's okay. So some other support mechanisms that are in place around the country, we've got the Renewable Energy Target, otherwise known as the RET, which is another certificate scheme similar to the VEU. It offers small technology certificates, or STCs, for heat pump hot water systems. And these are available, again, nationwide, and they are stackable with local incentives as well. In most cases. The Australian government's also launched a Social Housing Energy Performance Initiative, otherwise known as SHEPI. It's an $800 million investment co-funded with states and territories to become about $1.1 billion in energy performance upgrades. These include installing heat pump water heating and heat pump for space heating and cooling in social and community housing. And this is expected to impact around 100,000 properties with a mix of upgrades. We've got some low interest loan schemes, including one that recently concluded in Tasmania, one running in the ACT. And nationally, we've also got the Home Energy Upgrades Fund, which is a federal program unlocking $1 billion in finance for energy efficiency retrofits. This one is generally aimed at larger renovation projects, but heat pumps are among eligible technologies. Next slide. So now we bring ourselves to the challenges and opportunities segment. I'm sorry if you just bear with me. My screen's just done something funny and I'm trying to get it back. I'm back. So challenges for Australia. We've got some skill shortage issues. So we definitely do not have enough electricians, plumbers and refrigeration technicians to do the kind of upgrades that we're looking for, much less to handle our new construction needs and our clean energy build out. The lack of harmonisation between our jurisdictions is problematic. We are having some challenges with our National Construction Code, which I mentioned. So all of this can make things difficult at scale in a smaller market like ours. Our standards and regulation does tend to lag behind international peers, and this is a challenge. For example, we are only just now about to launch a minimum energy performance standard for heat pump hot water systems. And we're behind in a lot of other ways. We've also had challenges with well-intentioned boom and bust programs and incentives. So the government invests lots of money in a program, pulls that program, and it damages the market. That's happened a number of times. And we've also got some challenges with local manufacturing. A lot of our local manufacturers of these products were in gas products. So as we electrify, there is a bit of a risk to losing those manufacturers or that capability. Next slide. And so for our opportunities, electrification itself is a big option. There's a push to electrify everything. And I think that push is going to get a whole lot harder now. We're experiencing an oil crisis. I'm sure everybody on the call is thinking about that from where they are. So this itself is an opportunity, putting heat pumps in pole position for space heating and cooling and for water. And of course, obviously some industrial applications as well. Again, we've got a lot of states and territories wanting to transition away from gas, specifically to meet our emissions reduction targets. Victoria is no different, so there is an understanding that we need to do that. So this creates an opportunity for these technologies again. We can reform our standards and regulatory environment and do better than we have been doing, and fingers crossed we see a bit of that in coming months. Our energy efficiency schemes have the opportunity to be reformed. The Victorian Energy Upgrades Program I was just speaking about is currently undergoing a major review so that it's fit for purpose into the future, to help with our electrification agenda. And local manufacturing, whilst a challenge, is an opportunity. Among all that electrification, there is a chance to bring our local manufacturers along with us and unlock opportunities there. So that's it from me. Thank you.
Thank you, Rachel. Thank you so much for that presentation. Thank you to everyone who has joined us in the middle of this webinar today. A little bit housekeeping. We are recording this session. It's also being live streamed on our YouTube channel. If you have any questions or comments towards any participant or any speaker, please do use the Q&A box at the bottom, or you can chat to us on the chat box too, and you can address it particularly to us individual speaker. I'd like us to now shift our attention to Indonesia, which is represented by Totok Sulistian, who is the director of PT Narama Mandiri and is an energy consultant with more than 20 years of experience in both green building and energy auditing. His expertise spans from energy efficiency and sustainable development, particularly in buildings industry, with a strong focus on integrated design approaches for delivery of high performance and net zero emission buildings. In particular, he has contributed to the SEA and energy management programs, as well as the ASHRI, and is the co-founder of the Green Building Council Indonesia. Welcome to talk. We're ready to listen to you. Thank you.
Thank you very much, Rehema. Can you hear my voice?
Yes, we can hear you.
Yes, thank you. Heat pump technology is not longer just alternative, but a crucial part of national and energy efficiency strategy. Regulatory support and cross-sectoral collaboration, of course, it will accelerate their adoption in industrial and building sectors. But not like in Europe or New Zealand, explained by Glenn, and also in Australia, explained by Rachel, that implementation for heat pump is not, it's very rare if you are talking about in residential, but of course dominate installation in industrial sector and commercial building. Even in commercial building, it's still a few implementation for heat pump technology. And let me just start from the commercial sector that actually right now the driven for energy efficiency is driven by the regulation of green building. It's become mandatory, especially for governmental building. And also talking about industrial sector, the opportunities that there are a lot of program related with green industry in Indonesia. And of course, population heat pump in Indonesia, it's a high capacity system, not the small capacity. That I just interested to be here to get the figure for small size of heat pump. Next, please. Next, please. Yeah. Yeah, this is the market size, and sorry, back one slide. Yeah, this is the market size and share sources. So the current product, it's dominated by Daikin, Mitsubishi Electric, Panasonic, Fujitsu, and Johnson Control. And in 2020, I just collected from many different resources, many different reference. The potential for Indonesian market is 2025 is about 1.34 billion, and we expected that 2030 it's can almost double, 1.85 billions dollars. And then if we see the market share by the type is of course dominated by air sources, not the ground sources, or combined between water and ground sources, but dominated by air sources. And market share by installation, it's for new building rather than retrofit and replacement. But hopefully with the different regulation, it will be retrofit and replacement for the building. It's will be another opportunity. So this study is actually from 2019 up to 2030, and this year is 2024. Next, please. Talking about the energy conservation regulation is actually based on government building number 33 2023. And of course, if we look at the industrial sector, the currently actually the energy consumption is dominated by industrial sector. And you may see that the share of energy demand for this sector, industrial sector, is almost 50%. It's like a 45.6%, and then followed by transportation sector. Yeah, actually, 3-4 years ago is dominated by transportation, but now industrial is leading, and then building is at 16.8%. It sum with household sector and commercial. So household it's like a 12.4%, and commercial is at 4.4%. Even the commercial building is very low, 4.4. If we look at the growth rate for the building sector in Indonesia is, I think, more than double compared with the global growth rate of the area, the growth rate area for the buildings. And of course, household also the potential. For example, since the Ministry of Public Work that during starting from 2015 is actually accelerating for low-income housing. It's about 1 million house every years, and then now actually even the new government it's triple targeted, so it's about 3 billion housing every years. And of course, the potential heat pump in Indonesia is, I think, will be also very high in residential. Next, please. So this is the base for energy conservation regulation. Of course, it will be related with energy conservation implementation. It's not only downstream, but also upstream, started from management and downstream management, and then conducting the energy conservation is there will be several regulatory ministry regulation. It's supposed to be like 6 or 7 more technical and so on, and then obligation to carry out energy conservation for downstream side. and then also parties that conduct periodic energy audit. Energy conservation financing now it's also becoming attention for the government. And then business development, ESCO model, and so on is also part of the regulation. And then cooperation on the field energy conservation. I think many international funding right now is supporting the government regulation, and of course facilities incentive and disincentive also part of important regulation. Next, please. Yeah, talking about energy efficiency financing task force and also energy saving insurance. Right now, it's very new regulation, and the purpose is coordinate stakeholder to improve access for financing. And I myself also involved in preparing matchmaking between financing scheme and also industrial who need energy efficiency, who need financing and so on. Actually, it's so-called ESCO incubators. It's under Ministry of Energy and Minerals in Indonesia. And then energy saving insurance is also another concept that it's currently still trying for different pilot project in Indonesia, especially for industries and buildings. Next, please. So market-based instrument, MBIs, of course, we expected that up to 20 years, green energy investment exceeding more than 30 trillion in rupiahs, and applies for pioneer sectors, including renewable HVAC. But unfortunately, a specific program related with heat pump is not really stated on different type of regulation. Tax allowance, like a 30% deduction of a 6-year investment in tangible fixed asset, included accelerated depreciations, withholding tax 10% for foreign investor, and yeah, especially for the special economic or the new capital IKN, because especially designing for the building in new capital city is have to fulfill the requirement for green building, and also related industrial will be comply to green industry and so on. It's like a data center, like another supporting industry there. And then carbon tax relief, I think this is hopefully heat pump can be part of this mechanism. Carbon credit monetization. So this is also because of related with program of related with the environment, cap and trade high cell emission allowance, and then support net zero emission goals 2060. And then VAT import duty exemption, it's also can be implemented for heat pump. And then green bond and JETP funding, I think right now is the biggest funding. It's collected together in Just Energy Transition Partnership, what we call it JETP, and now many project and also pilot is funded by this mechanism. Next, please. So the opportunities and recent positive, of course, the growing use beyond traditional HVAC and government efficiency policies, rapid urbanization and new construction. You may see that the CAGR is positive, 2.3, 1.7, 1.3. And then geographical relevance is, of course, national urban centers, national major cities, Jakarta, Surabaya, Bandung, Medan, and so on. And of course, target for green building by Ministry of Public Works is actually right now not only in big cities, but also will cover in village in many cities in Indonesia. So there is MOU between cross-sectoral ministry, Ministry of Energy Mineral Resources, Ministry of Public Work, and also Ministry of Administrative National. And then growing the use of heat pump beyond traditional heating and cooling. I think it's even if you are talking about residential, it will be appropriate to be implemented in medium and high income for the society, and then implementation of government policies and initiative promote energy efficiency system, especially for HVAC. It will be related with specific buildings like hospital, like hotels, and so on, but not in the office because there is no heating requirement. We need cooling. So rapid urbanization, of course, especially when special target special area that there is complex or provided by the government. Next, please. So challenge and key barriers limiting heat pump deployment, of course, the installation complexity and cost, investment costs. I don't think that ground source technology is more appropriate and very expensive. Currently, as I know, in Indonesia is only air resources heat pump is implemented, and especially in hotels. Limited public awareness, and then I think I will include some case study in the last presentation, and then technician shortage and slow training throughput. Even, for example, seminar or FGD in Indonesia talking about heat pump is already conducted many times. Next, please. Heat pump application. So this is especially implemented in industry and building. So like a terminal reheat, and then domestic water heat, dehumidification. For example, many hospital that will be certified for green building, I think it's very appropriate to use heat pump because high humidity. We can use dehumidification for heat pump. Also, our project, it will be approved by the owner because this is new technology. It's not easy to convince the building owner to buy new technology. Recent industry development, like for example, Daikin, and also another brands is actually already prepare with new refrigerant, for example, R32 and so on. Next, please. This is the last slides is actually some example for heat pump. This is installed in Bali, and this is air source heat pump with the capacity of 30 kilowatt in one of hotel, Movenpick hotel in Bali. Then next, please. This is also in Bali. This is the small size modular air sources heat pump 80 kilowatt in Hyatt Sanur Bali. The total capacity is 80 kilowatt. And then also still in Bali, in Andas Hyatt Hotel, is also air source heat pump. Then the last example is yeah, it is next please. I think it. Oh yeah, this is installed in Central Java. And next please, one. The last two technologies, yeah, actually this is in small hotel in Central Java, and I think this is the it's relatively new. I think last year or this year it's installed with you may see that the replacing boiler with the messy condition and very neat, very big size, and if you replace with the heat pump, it's only small, only maybe 1/4 area you need it for installation. I think that's all from my presentation, and back to Rehema. Thank you very much.
Thank you so much, Toto, and thank you for the examples which puts everything into context, and for even highlighting how cooling is moving from just housing, or heat pump use is moving from cooling in houses to now under industries like food processing, hospitality, and others. Thank you so much. To all our participants, once again, if you have any questions to the speakers, please leave them in the chat box or in the question and answer section. If you do not have access to that, please do write us a question in the chat. We will see it. Our next speaker is from India, and he is Prasun Pandey, who is a manager at CLASP and brings more than 8 years of experience and is in the industrial decarbonization, energy efficiency, and other low carbon sections within the organization. So he provides technical and programmatic support to CLASP and holds a CLASP on project on cold chain in India. And before joining CLASP, he worked with Zintel, where he helped to business development, business development, and implementation sustainable growth strategies. Welcome, Prasun. Please do tell us a little bit about heat pumps in India. Thank you.
Thank you, Rehema. Good morning and good afternoon, everyone. In the next 10 minutes, I will walk you through one of the insights from one of the market assessment that we conducted in India. So I'll get going. Next, please. And before we deep dive into the technical content, I would take a few seconds to introduce CLASP. So CLASP is a global not-for-profit that works to improve energy and environmental performance of the appliances and equipment that we use every day. And in doing so, we accelerate our transition to more sustainable world. Next, please. As I said, CLASP is a global not-for-profit, so we work in a host of countries. Next. I heard previous panelists from Australia and New Zealand, and where the market is far more matured. Compared to those countries, the market in India is still growing, evolving. If I would have made this presentation 5 years ago, I would say the market in India is conceptual one. Now the situation has improved, while the market is still nascent, but it is no longer a conceptual one. And the study that we conducted in the past 1 year, we realized that there is some sort of organic growth that is happening in the market. We estimated that roughly 665 megawatt thermal equivalent capacity is installed in India as we talk. And largely the penetration of heat pumps for water heating use case has been largely around in the commercial segment, followed by some bit of residential, and industrial is the minor segment. Now, if we look at India's geography, you would see India is largely a global south. So while there isn't much demand for space heating, space heating in India, but nonetheless, the products which are more publicly available in the market are air source heat pump times. And that is essentially because of the reason that in India, there is a huge air conditioner cooling market. And some of those products also have functionality to work as heat pump and provide heat pump space heating functionality as well. So if you look at a product randomly in the market, it is likely an air source heat pump that dominates the market. And applications that we found in Indian markets were largely around hot water, space heating in the northern part of India, and industrial, though I'm referring it here, it was pretty non-existent. If you look at the overall market in terms of there is very limited domestic manufacturing of heat pumps in India, and we tend to import most of our heat pump technology solutions largely from China. As you would expect in the residential segment, the sizes are pretty small, 2 to 6 kilowatt, and in commercial it ranges because it becomes a bespoke product for the consumer, so it ranges from 2 to roughly 2,000 kilowatt. Next one, Rema. Now, talking about the policy and regulatory ecosystem in India. Again, I would refer to the previous presentation. In New Zealand and Australia's presentation, you would have seen that we were talking more about integration of heat pumps in building codes. But in India, the market is still evolving and the product itself is not established yet. So as you see in my slide, most of the early action that is happening in India is on defining the heat pump as a product. And in that case, in India right now, certain set of product standards are evolving. So if I talk about IS 1391, that essentially is a product standard for AC, but that has a component on defining how can an AC work as heat pump as well. So these things are evolving. In market, we have also seen evidence for VRA for the larger ACs. So these products are increasingly having heat pump functionality integrated into them. But nonetheless, the market and the product standards are still evolving. Now, having said so, I mean, though the policy and the regulatory space, I mean, one may feel it is slightly pessimistic, but if you read through the green boxes that I have provided, so the draft standard for heat pumps for water heating purpose has been just now circulated by the Indian Standard Authority. So that has been excellent development, and that should kickstart certain discussions in the market. The other aspect is that while air conditioners in India have heat pump functionality, we don't rate them for energy efficiency as such, because in India we have not yet defined heating bin hours or temperature ranges. And in that sense, they are available in the market, but there is no indication about their APF or efficiency levels. Of late, certain work has also started in this domain. There is an ongoing work to define heating bin hours and temperatures. And once that is done, the space heating ACs come heat pumps could also be rated for energy efficiency. So there are some good developments that have happened in the past 4 or 5 months that should enhance the policy space in India. Next. Now talking about public finance or the financial incentives. So you would not find any dedicated program incentive or of any sort for or concessional finance for heat pumps in India, be it any use case. But our research has indicated that in some of the industrial and small and medium enterprise related efficiency programs, the heat pumps are not, could be included. If someone wants to go for them, they might be eligible for certain concessional e-finance, but these have not been specified very clearly. I'm talking about finances. Our study did highlight that upfront cost is a major barrier for all the consumer types in India, and payback ranges ranges from 1 to 9 years. Obviously, in case of industrial, the payback is far more smaller, but in residential, the payback is pretty long. And the reason is that a typical electric resistance water heater type is type water heater is available for a fraction of the cost. So that is the big deterrent. Next slide, Rehma. Now, having talked about finance, I would also like to delve a bit deeper about the other challenges or barriers that we see for the heat pumps in India. Now, one key takeaway for us was that technology itself is pretty mature, but the whole ecosystem has not evolved yet, and that is hampering the adoption of heat pumps in India. One of the major barrier, at least for water heating use case, is low awareness. Most residential consumers do not know about such technology type. And as I had highlighted in previous, even if someone gets to know, the high upfront cost makes it pretty much unviable for them. Now, the second is the market itself is fragmented. There are a range of products which are available, but people are not sure about the product quality, their functionality. And in the same way, domestic manufacturing has not been able to take place for heat pumps in India just because it uses certain high-tech components like compressors and heat exchangers, which India has not been historically good at manufacturing within the country. And a few other things that I would like to highlight is uh, there is non-existing testing infrastructure for such products in India. So if product is not certified for safety and performance, I mean, the consumer's confidence is going to be low in such technologies. And and largely the demand itself is pretty low. Next slide, Rehma. We assess the potential for heat pumps in India, and we looked at 2024 potential and 2030 potential. Obviously, in our analysis suggested that there is India's potential for heat pumps jumps 3 times from 2024 to 2030 timelines. And if you look at 2030 potential, you would see that water heating is the major use case. Almost 80% of the potential that we assessed belong to water heating. And within that segment, residential is close to 87%, followed by commercial. Now, using these insights, CLASP has been trying to develop, inform our work in India. That I'll talk in next slide. Next slide. So, Rama, please go to next. So having recognized that residential water heating is the most dominant use case for heat pump adoption in India, we tried to look a bit deeper as to what are certain barriers that are hampering their adoption in India. The first and foremost, I had covered in previous slide, and no harm in repeating, is lack of awareness about technology among the residential consumer. The second, we realized, like in the commercial segment as well, it's the end consumers like hospitals, hotels, and other commercial establishment. The end consumer doesn't necessarily know and decides this technology, and the market is still driven by the consultants and architects who advise them how to essentially design facility building management. So there wasn't much awareness on those consumers and these consultants as well. And the third and the most important is the missing ecosystem. There was no certification about the performance, safety, and all those. So recognizing these challenges, what CLASP has been working in the past 1-2 years is that we have been trying to work with stakeholders in India to assess the potential of labeling such technologies in India. And why would labeling help? Because once this product is labeled, it would help build consumer confidence in the technology. And if the product is tested well enough in the laboratories, it would signal the safety and reliability of such technologies. And the label can also spur a whole lot of other market actions. So, for example, if a product is recognized in a country's energy efficiency regime, they might also be preferred in various type of government procurement that may happen for government buildings for water purposes. And then lastly, we also thought that if labeling program comes, it would also help create a whole lot of testing and certification ecosystem. So considering all these barriers and potential solutions, the CLASP has been working with agencies, Bureau of Energy Efficiency and Bureau of Indian Standards in India, to first develop product standards and test methods, and also incorporating an energy efficiency parameter in those product standards. And then we are right now collaborating with Bureau of Energy Efficiency as well to drive a labeling program for heat pumps, essentially for water heating use cases. Next slide, Rehma. Now, having covered largely the water heating use case in India, if we look at the future that holds for heat pumps in India is essentially driven by multiple country-specific priorities. So while India is adding renewable capacity to its grid very rapidly, our assessment did also hint that most of the industrial process heat is still fossil driven. So this creates a huge opportunity in India for heat pumps. We can essentially explore heat pumps for electrifying the process heat requirement in industry. The second consideration for India is electrification. So as we speak, India's electrification is slightly on the lower side, and especially in the case of industry, it's just 17%. Now, heat pump it's a very opportune solution for India because it can help deliver multiple competing priorities through one solution. One is essentially electrification, energy security, because in India, as I said, we are increasingly deploying renewables, and so we would be replacing fossil with electricity. Efficiency, as we all know, they do tend to deliver 300 to 500 efficiency as compared to typical solutions. So that is one benefit, and industrial decarbonization is definitely in India's goal. So what I'm trying to say is right now, India is not positioned as a cross-cutting decarbonization solution. There are certain organic discussions within the stakeholders and the market for certain use cases, but there's a need in India to position heat pump as a cross-cutting decarbonization solution. And once that is done, probably we can try to build those segmented market in phased manner. What I mean by phased manner is essentially right now the focus is on water heating use case. Once this market segment is adequately addressed, probably we can focus on industrial process heat and then subsequently space heating. And the good thing with heat pump is that there is a whole lot of global momentum on heat pumps across Europe and other countries. Probably we could leverage the interest and activities in other part of the globe to leverage certain best practices for India. So with that, I conclude my presentation, but I'm open to question. And Rehma, back to you.
Thank you so much, Prasoon. That was really good. Particularly, I would love to get my hands on the draft standards for heat pumps, particularly for water heating. So thank you so much. Our last speaker is from Thailand, and this is Dr. Piatida Trinuruk, who's an assistant professor at the King Mongkut University of Technology, Thonburi in Thailand. She specializes in energy systems, thermal technologies, and energy efficiency. And her research has focused on sustainable energy solutions, including heat pump technologies, thermofluid systems, and energy-efficient heating applications. Harry, welcome, Dr. Piatida. Please unmute yourself and kindly keep your camera on during the whole presentation.
Okay, thank you, Rehma. And good afternoon, everyone. My name is Piatida. So today I would like just to share the experience on the overview of the Thailand heat pump market landscape and the policy framework. So next, please. Yeah, first I just want to draw you to understand our background about the air conditioning system and the heat pump. Thailand is a key global manufacturing center for the air conditioners. We are the third largest exporter for the air conditioner, following the China and the Mexico, and also the main player for the domestic market for the air conditioner is just residential sector. But when we talk about the heat pump, most of the people in Thailand just train to associate them with the hot water application, not just for the cooling application. So for the development of the heat pump policy in Thailand is begin around 2013, as shown in the map. And this program is starting by the Department of the Alternative Energy Development and Efficiency, or we call DEDE. This department is under the Ministry of the Energy. And the policy landscape has been developed significantly from the initial energy efficiency initiative to more advantageous framework supported by the international collaborations. Next, please. For the overall market of the heat pump in Thailand, it seems like it has the experience significantly growth. You can see from the chart that, a large portion, around 80% of the share market is dominated by the overseas brand, for example, like from Japan, China, and United States. For the local brand, we have just only 20% of the share market. This is because of the positioning between the cost driven from the China manufacturers and the well-established Japan and United States brand. And this has created a clear market gap, particularly in the high-capacity industrial system. For the heat pump technology in Thailand, most of them, we are talking about the air source heat pump. And this technology is dominated about 72.6%. And highly performant in the commercial sector. Next, please. And to strengthen the adoption of the heat pump in Thailand, the MEP, the minimum energy performance standard, and the HEP is the high energy performance standard has been implemented. For the MEP, mandatory regulated by the TC. TC is a Thai Industrial Standard Institute. This standard acts as the safeguard to prevent the low efficient equipment from entering the market. And for the another hand, the HEP is represented by the DEDE. They represent where the high efficiency level. And this is a voluntary program, but designed to promote the high performance heat pump by targeting the top tier of the heat pump in the market. Under Thailand Industrial Standard, TIS numbers T626, this standard has been developed from the international standard number EN 2.5-T, but we are adopting the testing condition for Thailand weather data. The testing condition test at the ambient temperature around 36 degrees Celsius, and the water temperature was set up just only 55 degrees Celsius. And the criteria of the COP for the minimum requirement is set at the 2.4, and the high efficiency heat pump is expected to achieve the COP higher than T.0. From this standard that has already, mandatory in Thailand, the maximum capacity for the heating capacity of the heat pump just cover only 36 kilowatt. Next, please. To accelerate the adoption of the high efficiency heat pump in Thailand, it's very important to have the three pillars. The first is the data and the standard, that's already mentioned. The second one is the financial support. Among these, the financial support is quite very important driver to accelerate the adoption of the heat pump in Thailand. Thai government has developed a comprehensive financial support framework. For example, the direct subsidy, which is provided via the ENCON fund, particularly under the DEDE 80/20. That means the support was covered about 20 to 30% for the investment cost, and the cap is just up to 3 million baht. And the second program we call like ESCO revolving funds. This is they provide the equity support to helping the mitigation on the technology and the financial risk for the large scale project. And the last one we call like the soft loan program that is available through the commercial bank, for example, like Kasikorn Bank, Bangkok Bank. This program is offered the delicate green financial scheme with the preferential interest rate. So next, please. For the third pillar, that is should be, promote for our heat pump. It should be capacity building for the international collaboration. This is some example of the recent project that we have collaborate with the international partnership, such as the JICA and the METI from Japan. And two program play an important role in the knowledge transfer and technical developments. One of the main challenges in the gap between the current testing capacity and the industrial requirements. At the present, you can see like Thailand, where our infrastructure is just limited for the small scale system. The heating capacity just below 36 kilowatt thermal, and the temperature is lower than 55 degrees Celsius. But in the other hand, for the Japan, the testing standard was facilitated for the industrial scale, and the high temperature was introduced, for example, like 65 degrees Celsius or 90 degrees Celsius. And also it can implement for the air source and the water source heat pump. But our facility just limit for the air source heat pump. So from this collaboration, the government, take the action to take into account for the upgrade our standard to build the local technical capacity. So next, please. However, you can see like there are still have some challenge in the market of the heat pump, especially for the high initial investment cost. That is quite very important, I think, even in the Indonesia and the India, and also the limitation on the testing gap, especially right now, we are just limit for the small size of the heat pump. And the last one is about the knowledge. We are still lacking the knowledgeable engineers for specialists in the system integration and design. So to drive the heat pump market, I think the important thing it should be like try to promote the project that can be, have the payback period lower than 7 years, and also introduce some sustainability by reducing the CO2 emission. One of the project is using the heat pump by replacing for the fossil fuel boiler. And the last one is try to give the knowledge to the people about what is the high efficiency from the heat pump technology. So next, please. However, if you can say, sorry for the opportunity in Thailand, if we can see like right now for the commercial sector, most of 90% has already adopted in the commercial sector, especially for the hotel, the hospital, and the rentals. But in the industrial side, it's quite still the challenge for the heat pump technology. We can approximate right now in Thailand, we have like 10,000 boiler and about half is using the fossil fuel boiler. So from the approximation from the one study, they approximate like we should have like at least 1,500 company that have the potential to, replace the fossil fuel boiler to be the heat pump. Anyway, there are some criteria quite very limited. First is the facility in our lab is still limited at lower than 36 kilowatt and the temperature is at 55 degrees Celsius. Next, please. So before I stop my talk, so just leave some message to how we can, accelerate the industrial heat pump in Thailand. So first, I think the clear policy roadmap should be addressed, especially for the heat electrification. And the second one for the incentive scheme, I think it's quite very important. And the third one should be the readiness in the local supply chain. Even we have a lot of the air conditioner manufacturer, but for the heat pump, the local supply chain is quite very limited. And another things is the capacity building in the human resource, especially for the industrial heat pump system integral. So, okay, next please. So thank you for your attention.
Thank you, Dr. Piatida. That was very insightful. Thank you so much. Now we shall move on to a very short session of question and answer, and I know time is usually not on our side. I would request that each speaker has assigned the questions in the chat box. Peter will ask them as well as Duncan, where you have any questions to the speakers. Please use only 1 minute to answer your question. Over to you, Peter.
Thanks so much, Rama, and thank you, everybody. Really interesting and diverse contributions today. So we have some questions directed to each one question to each of the panelists, and so I'll just go through them in order. So, Glenn, at the beginning, you mentioned that you had a program that solved split incentive problems with landlords. Can you quickly explain how that worked? Because it's a big problem for many markets.
Yeah, it certainly is a big problem, Peter. The go-to option for rental properties in New Zealand was simply providing, a 2 kilowatt electric resistance heater, which, wouldn't have any hope at all of keeping a living room warm. So the Healthy Home Standards regulation was phased in from about 2019 until it was mandatory by the middle of last year. And basically that required all privately owned rental properties in New Zealand to meet minimum standards in terms of insulation, heating, ventilation, draft stopping, and moisture ingress. And there was a process by which everything needed to be checked off, and the heating requirement was assessed in order to provide 18 degrees temperature in the main living room. And then that related to a heating requirement, which might be 6.5 kilowatts, for instance. So then the landlord was obliged to go out and acquire a fixed method of heating that produced that 6.5 kilowatts, and that needed to be signed off as being compliant. And a number of businesses popped up in New Zealand over the last 5 years doing those assessments, and a lot of heating providers diversified into that area because it was a huge business opportunity. And I mentioned heat pump sales in New Zealand have been about 200,000 over the last few years. Well, they peaked in 2020 at 270,000, and part of that would have been those people, making sure that their rental properties were compliant with that new regulation. So that's now in place. Every rental property has to meet that, and it's been quite successful at lifting the standards for the warmth and healthiness of rental properties in New Zealand.
It's fantastic. It's great to have confidence in compliance as well, which is
it's not without its problems. There's always problems, and people will try and get around it. But by and large, I think it's done a good job.
That's fantastic. Rachel, you mentioned, I think, that there were some initiatives which might have hindered the market somewhat, and I didn't catch what they were, but it sounds important. what doesn't work?
Yeah, sure. So using heat pump hot water as an example, there are sort of two key ways. One being increased uptake without the right regulatory oversight and without minimum energy performance standards for products did lead to lower performing or poorly installed products in the market. And this has caused some reputational issues for the industry at points. Heat pump hot water systems, and it's not a new technology, but it's new as a more dominant technology here. Many plumbers have never been trained formally in how to install them. And then you've got large programs rolling out. You can imagine challenges there. So that's a challenge that we've got to overcome, and there's still some problems there, but we're getting better. And then the other one is when large programs are introduced but then pulled prematurely, like we've witnessed market impacts of that. So in 2010 there was a pretty generous incentive for heat pump hot water systems from the Australian government. We got up to about 72,000 of them installed per year. The incentives were pulled away. It went down to like 20,000 a year. And then in 2020, several states brought in some new incentives and it increased, it quadrupled from there. So that just shows that the government can drive the market, and that's a positive thing when you're looking to stimulate certain behaviour. But at the same time, with great power comes great responsibility.
Yeah, preparation it sounds like is an important aspect to that.
Absolutely, yeah.
Yeah, but it's good to see that you can actually you can, as you say, drive it. So that's good. I'm breathless now with the timing, but if it's okay, we might just go a couple of minutes over just to pay respect to the expertise on the panel here. There's a number of questions for Totok, but I would like to pick one. Perhaps Totok, you mentioned that there were market-based instruments that were being deployed in Indonesia. I wondered which ones have been most successful in terms of uptake at the moment, and perhaps which ones aren't so well subscribed at the moment.
Yeah, thank you, Peter. Yes, I think the most popular and successful instrument is what we call it energy efficiency obligation scheme, and also utility obligation, for example, because for right now the regulation related with pointing out energy manager in industry and building is mandatory for certain size of the industry who using more than 4,000 ton oil equivalent for industries, and then for building is 500 ton oil equivalent is mandatory, and also obligation to conduct energy audit and so on. And then it can be combined with the regulation right now. It's just released in the beginning of this year regarding ESCO market and major. And of course, the international funding right now is also coming, like UK PEC. I know that GBPN also part of stream in the UK PEC program, and I also involved in that project. So piloting for industry and building, I think it's also driving that we can implement for piloting project. And energy saving certificates, I think it's also important to be implemented. I don't know the concept of competitive auction for energy efficiency, for example, when the Ministry of Public Work, they conducting build the low-income housing, for example. So its energy efficiency can be part of competitive action. Less successful is challenging instruments. Of course, it will be related voluntary carbon market for energy efficiency. I think the government is still trying to put with different scheme, and also unstructured subsidy or rebate program. I think it's still prepare for the across sectoral with OJK, with Ministry of Industry, Ministry of Finance, and so on. Hopefully it's answered your question. Thank you.
Absolutely. Yeah, thanks. I think it's also a long-term effort to get some of these programs accepted in the market too. I might hand over to Duncan if it's okay. As there's a couple of questions, one question or two questions, one for Prasanna and the other one for Piatida. So Duncan, over to you.
Yeah, thanks, Peter. And thanks to our panelists. Really interesting presentations. It's been a real treat this morning. So for Prasanna, I'm wondering, within the residential sector, are there certain building market segments where you see a higher potential for heat pumps compared to the others? I mean, where do you see the most heat pumps being installed in India in the future?
Thanks, Duncan. So, Duncan, in our study, we did not sub-segment the residential segment, but just to answer your question, with increasing urbanization and increasing aspiration for better comfort in homes, our guess at this point of time is it's likely mostly urban homes. The new wave of high-rise apartments and the standalone houses that are going to be built in the urban India. Now, having answered that, I would also like to make a distinction between the potential market versus the actual feasible market. So while residential has a huge potential, our thinking of late has been shaped that it is more commercial viable in commercial buildings. The facilities like hospitals, offices, hotels are going to drive the next set of market demand. And pretty much the reason has been highlighted previously by other panelists. A resistive water heating geyser is available between $50 to $100, while heat pump starts at $300 or $400. So it's very difficult for residential consumer to make that move.
Thanks very much. And then last but not least, we'll turn over to Piatida. And you mentioned the importance of low-cost heat pump brands to Thailand, and also the role of Thailand's minimum energy performance standards and its high efficiency performance standards. Could you talk a bit about how low-cost brands are able to meet the MEPS, the minimum energy performance standards? Thank you.
Oh, okay. Well, actually, we have just a few companies that has a local brands, but most of them that have very engineering knowledge. They can, develop our local heat pump, and we can make the HEP and MEP. So the efficiency is quite very good for our development. But I think the cost competitiveness cannot, win with the Chinese brand. So that's our problem in Thailand. But for the technology, yeah, I believe the Thai engineer can do it.
Absolutely. Good to hear. Good. Thank you very much. Thanks to all the panelists. So I guess at this point, we'll hand it back over to Rahima. I believe someone is giving some closing remarks for the event. So thanks.
Thank you, everyone. Thank you, all the speakers. Thank you to Peter and Duncan for the lovely accommodation. I have been your host, Rahima Kabari. I'm the Heat Pump Project Associate at GBPN. I will now hand over to Agora Energiewende, who will give us the closing. Thank you.
Thank you so much, Rahima. I just want to say thank you so much to all our speakers, Glenn, Rachel, Prasun, Tatuk, and Piatida. You've given such a rich and insightful contribution to this discussion. I only wish we had the whole day because there's so much to unpack, and I'm so grateful for those contributions. And of course, to our moderators, Peter and Graham, thank you. Peter and Duncan, thank you so much for guiding the conversation and really adding so much meat in your introductory comments. I think what we've had today is sending a really clear message, reinforcing a very clear message that accelerating heat pump deployment is really a critical pathway to decarbonization. And it's one of the largest and most challenging sectors globally, and each of us in our different roles and spaces are contributing to this, and that's both in the mature markets and the emerging economies. And we're really excited in terms of moving forward, in terms of how we shall work towards developing stronger policy across countries, how we can enable and develop innovating financing, and really continued knowledge exchange across regions, very similar to what we have done today. In terms of next steps, I want to encourage everybody who has been part of this. We shall make this webinar available on GBPN's YouTube channel. We encourage you to revisit it, share it within your networks. It will be posted, a link to our YouTube channel will be posted on the chat. Please spread the word. We also welcome you to view the Heat Pump Toolkit version 2.0 that has been developed. It's available also on a link in the chat. Take some time, look at the toolkit that was developed in partnership with CLASP, RAP, Agora, and really get engaged with it. Should you have any additional questions, or you may just want to follow up with one of the speakers, please reach out to the GBPN team through Rehema. An email address will also be posted in the chat. Please feel free to reach out if you'd like to connect to any one of our speakers. We encourage all of you to take forward the insights that have been shared today, whether it's in your policy work, market efforts, research, and really just continue contributing to our collective momentum around clean heating and cooling solutions. This isn't the end of this conversation. It's really part of a growing global effort to accelerate this. A very special thank you to the GBPN team that has put together this session. We have Rehema, who has guided the session so wonderfully. Alvin, Cello, Patience, and Stacy, thank you so much for all your help and input in making today's webinar a success. And lastly, to all the attendees who have made time to be part of this conversation, thank you for joining us, and we're looking forward to a continued collaboration. And just to everyone, have a wonderful night, afternoon, or morning, depending on where you are, and have a wonderful day. Thank you so much.
Thank you, team. Thanks, everybody. Bye-bye.
Bye,
Thank you,
everyone.
everyone.
Thank you.
Bye.